I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We'll look into solving trigonometric equations when the angle could be from 0 to 360 degrees in this particular video. We are going to apply the cast rule, find related acute angle, and then write the principal angle. And consideration of domain is important. Here is a fast-track trigonometric program which is available for you to register. You can learn many basic concepts of trigonometry and get ready for future. This will help you even for competitive exams and admission to universities. Our approach, engaging minds, really help you to bridge the gap and apply the concepts learned. See how in steps we'll develop the strategies and apply them in solving these examination questions. In case you want to learn from me, you can always send an email on the address given. Gain confidence and get ready for the future. Let's begin with the class now with Rohan. Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. So Rohan, today what do you want to learn?
So today I'd like to learn about trigonometric ratios when looking at angles from 0 to 360 degrees.
Okay, sure. So let me introduce to you this chapter, then you can take up questions from your book and we'll solve them one by one. Is that clear?
Okay, sir.
Great. So here is a whiteboard. Can you see my screen?
Yes, sir, I can.
Okay, great. So we'll begin by understanding what is 0 to 360 degrees angle and how do we really talk about them, right? So this is our coordinate plane. Normally we say x and y, correct? Let me write x and y, x-axis and y-axis. When we say angle, that means we are interested in that angle theta, right? So angle in standard form. So we have angle in standard form. When I say standard form, let's be very clear, it means that the vertex of the angle is at the origin and one of the arms is along the positive x-axis. We call this arm as the initial arm. Vertex at the origin O. The angle is always formed with two rays with a vertex, correct? So we are calling it arm. The other arm is which you open, right? Let's say they were together. That means it was 0 degrees when the other arm was here. Then you start opening up and you see the other arm. And let me draw the other arm. Okay, so let's say this is the other arm. We call this arm as the terminal arm. So they have the common point, which is called the vertex. And this movement, which is counterclockwise, right? Counterclockwise movement, that gives you an angle theta. And this angle is called the principal angle. So here, theta is principal angle.
Okay, sir.
So principal angle is the angle when the initial arm is along the x-axis, vertex is at the center, and the terminal arm is rotating counterclockwise. So we also sometimes will say counterclockwise means positive angle, and clockwise means negative angle. Perfect. So angle is measured from the initial arm as it opens counterclockwise, and that is treated as positive principal angle. Okay, so based on this, let me ask you a few questions. Let us say we have this particular terminal arm is here, right? And this angle given to you is, let us say, 60 degrees. Can you tell me what is the principal angle?
The principal angle would be negative 60 degrees because it's going clockwise, so it's going below.
Okay. And if I want to write it positive, then how much will it be?
And if you want to do it positive, then it will be 300 degrees because you do 360 minus 60 because 360 is a full rotation.
So you will say this is 300 degrees positive, correct? But yes, you are right. You could also say minus 60 degrees. Perfect. Because it went clockwise. Perfect. Most of the time, when we're talking about the angle, we will say measure the angle theta when it is between 0 degrees and 360 degrees. The whole idea is that if it is along this line, 0 degrees, if it is right here, 90 degrees, that is 180 degrees, 270 degrees, and then coming back to the original point after a full circle, this is 360 degrees, correct? So if the question indicates that you have to find principal angle between 0 to 360 degrees, then the only correct answer will be 300 degrees. You get the idea?
Yes, sir.
So while answering this question, you have to be very specific. Depending on the question, you have to correctly answer. Perfect. Now, let's also look into the second very important concept. Is this all clear? Can I clear the screen?
Yes, sir.
Perfect. So now you remember the cast rule also? What is the cast rule?
So CAST, where in first quadrant, all primary trigonometric ratios are positive. In the second quadrant, only sine is positive and tan and cosine are negative. In the third quadrant, it would just be tan that is positive and sine and cosine are negative. And in fourth quadrant, cosine is only positive and sine and tan are negative.
Perfect. Now, if my question here is that the principal angle theta will always represent theta as principal angle for this exercise today, okay? Is between 0 degrees to 360 degrees. This is what you are interested in. And if I say that sine theta is equal to half, in that case, what is theta equals to?
Theta would be sine inverse of half.
Which is how much?
Which is 30 degrees.
That is correct. You could also draw a special triangle, and without calculator also, you could find this angle. So you are saying sine inverse of half. If you use calculator, then you say theta is 30 degrees. Now, you know, sine, of course, will be positive in quadrant 1, and you're saying 30 degrees will give you sine half, right? Sine of 30 degrees half. But you know, sine is also positive in quadrant 2, right? So our answer lies in 2 quadrants. What is the other answer? Can you tell me the other answer? Because we are looking into all the solutions between 0 to 360 degrees.
150.
Perfect. So the other angle from the symmetry you can see is this much, right? In quadrant 2, making an angle of 30 degrees with the horizontal. Do you understand?
Yeah.
So this angle, which is shown here, is called related acute angle. Related acute angle is the angle between the terminal arm and the horizontal axis. It is always positive. Relative acute angle always positive. Between 0 degrees to, let me use alpha. Some books use beta, right? Let me write beta. Related acute angle between 0 to 90 degrees. Always positive, right? Angle between terminal arm and x-axis. Is that clear to you? So
yes, sir.
The related acute angle I could show here also. This is also 30 degrees. That is same related acute angle. However, sine is going to be negative in quadrant 4, right? So since sine is positive in quadrant 2, we say the related acute angle will be same and the principal angle will be 180 minus 30, and as you said, 150 degrees. And therefore, sine theta equals to half will have two answers in the interval 0 to 360 degrees, and the two answers will be 30 degrees and 150 degrees. Is that clear to you?
Yes, sir.
So that is what we mean when we are trying to find all the angles between 0 to 360 degrees. Is that clear?
Yes, sir.
Let's take another example. If I say tan theta is equal to square root 3, theta is between 0 degrees to 360 degrees. Find all solutions. What is the answer?
Tan theta is equal to square root 3. Would be 60 degrees, if I'm correct.
Correct. So when you make your special triangle for 60 degrees, we have 1, 2, square root 3 side. Sine is opposite over adjacent, so square root. So theta is 60 degrees. That is one of the answers. Definitely, you got the right answer, the first one, and that is it, right? You're saying this is your principal angle, 60 degrees. However, with the cast rule, you know there's another answer also, which is this, correct?
210.
So this 60 is equal to the vertically opposite angle 60, which is also a related acute angle. So the other answer is 180 plus 60 degrees. Is that clear to you?
Okay, sir.
So that is 240 degrees. You get the idea. That is how we are going to answer these questions. Clear?
So when I do only for sine, we just actually subtract 180 from our other angle, right, sir? But in sine and tan, we add them up.
It all depends which quadrants we are looking at, right? So if you're looking at this, obviously you have to add 180 plus, right? Do you see that? So don't try to remember, just try to see, visualize, and then get the concept. Clear?
Yes, sir.
Now let me take up another example using cosine. So now we are saying cos theta is equal to negative, let us say, square root 3 over 2. And theta as such is between 0 and 360 degrees. What could be the answer? To make things simple, I'm just using one special triangle. Can you tell me the answer?
So in general, causes theta. So theta, if it's equal to square root 3 over 2, it would just be 30 degrees.
Correct.
So,
But it is negative. So you find that the related acute angle is 30 degrees. Do you see that? This is what you did first, right? Forget
yeah.
about the sine. Related acute angle, I said, where the cosine value is positive. It is a bit less than 90 degrees. So all is positive, right? So basically, you are saying, well, this is my related acute angle beta, but this will give you positive value, right?
Yeah.
You are in quadrant 1. However, the question wants negative. That means if you use the cast rule, when is cosine negative?
In sine and tan.
In quadrant 2 and 3. So we will look for the angles, the principal angles in quadrant 2 and 3. Do you see that? So the related acute angle
Yes,
being
sir.
30, correct? What are the principal angles? Can you tell me? One is this, right? Which is
150.
180 minus 30, which is 150 degrees, right? So theta equals to this. And the other value is this, right?
To 210, because we're added by 30.
Correct. So our answer here is 150 degrees and 210 degrees. Is that clear to you?
Yes, sir.
That is how we are going to answer such questions. Let me take you another question here. And this time, the question here is, when sine square theta is equal to half, what is theta equals to? And we know we are looking theta which belongs to this time, see, I'm writing within square brackets, right? Do you see 360? It means that the angle is between 0 to 360 degrees. Can you tell me the answer now, please? Yes, sine square theta is half. Find the angle theta, where theta is between 0 to 360 degrees.
Wait, so sorry. So sine in general, so sine of theta would just be 30 degrees, which is
No,
equal to
sine
half,
square,
right?
sine square theta is half. Sine square theta is half. That means
Oh,
sine theta is what? Square root, right? 1 over square root, correct?
so square root 2 over 2.
Yeah, square root 2 over 2 you could write, or 1 over square root 2, but with positive and negative both, right? Because negative 1 over square root 2 will also give you half when squared. So whenever you do square root, take both positive and negative signs. You get the idea?
Yes, sir.
Now tell me, what are the solutions? So sine theta is now equal to 1 over square root 2 plus and minus. So that means we're looking into 4 solutions because we're looking into all, right? Plus and minus. So all 4 quadrants, correct? 4 different values.
Yeah.
What is the angle beta? Let us say, how do you find beta? Beta will be sine inverse of 1 over square root 2, correct? Which is
Yeah.
45 degrees. So now we know that each acute angle is 45 degrees. What are the principal angles? So the principal angles will be 45 degrees, right? Let me write theta equals to 45 degrees. Then this much, which is 180 minus 45. Right? 135 degrees. Then 180 plus 45. 225 degrees, correct? And then 360 minus 45 degrees, correct? 315 degrees. So this has 4 solutions. So
Yes.
theta is equal to 45 degrees, 135 degrees, 225 degrees, and 315 degrees. Do you understand? So trigonometric equation within the interval 0 to 360 degrees could have multiple solutions, right?
Yes, sir.
It could have sometimes no solutions, sometimes 1, 2, 3, 4, many solutions, right? So we had some examples which are 2 and 4. Now let me give you another. Sine theta equals to, let's say 1, and theta belongs to this set, 0 degrees to 360 degrees. Can you tell me the answer, please? Tell me the answer. So theta equals to?
90 degrees.
There's only one answer, correct?
Yeah.
If I say sine theta equals to 0, how many answers are there? Where theta is between 0 degrees and 360 degrees.
So if sine theta is equal to 0, then there would be 3 solutions in this?
Yes. Do you see that? So there could be many
Yes,
solutions,
sir.
right? If I say cos theta equals to square root 2, how many solutions?
No solution, sir, because
You are correct. So no solutions. Cos theta is always between plus and minus 1, right? So that's what you've learned. We could have many solutions depending on the equation, right? There may be no solution. There could be 1, 2, 3, or many solutions, correct? So we could solve equations like this to find the value of trigonometric ratios within a given interval, right? Sometimes I may give you a question which is something like this. Sine theta plus 20 degrees is equal to half. Now, we are given that theta is between 0 degrees to 360 degrees. Find the solution of this, tell me.
So what? So sine of theta plus 20 degrees is equal to half, right, sir?
Yes.
So wouldn't it just be, so divided by sine, you would just get theta plus 20 degrees on its own equals to 1/2 divided by sine?
So what we will do is that in such cases, I'll tell you a technique. So let us consider this angle to be some other angle phi. Is it okay? So we are writing sine of phi is equal to half, correct? So that means we will find basically, let's say, some angle phi. So half, and we know this is positive, means we are expecting two solutions. This we know, right? Now,
Yes, sir.
when is this sine phi equals to half? You also remember, when theta is between 0 to 360 degrees, then phi will be between what? Because theta plus 20, right? So that means 20 degrees to 380.
368.
Because we'll add 20 each side. Do you see that? Because theta plus 20. Do you see that?
Yes, sir.
So we'll add 20 here to find the domain. Is that clear to you? So phi should be between 20 degrees to 380 degrees. Now, we are saying sine phi is half. So let us first find the related acute angle, which is sine alpha equals to half. Let's use alpha this time and half. So when is sine alpha half? So it is 30 degrees, correct? So we know that this is my alpha. Is it okay? Acute angle, correct? Now, if that is one angle, the other angle should be this one, right? Which is 150 degrees. So we have two solutions for phi, which is phi is equals to 30 degrees or 150 degrees, correct?
Yeah.
But we have to find theta. So we'll write, replace phi with theta, and we say theta plus 20 degrees is equals to 30. Theta is 30 minus 20, which is 10 degrees. Is that clear to you? Or theta equals to 150 degrees minus 20 degrees, which is 130 degrees, correct? So we have two answers, 10 degrees and 130 degrees. Do you see how we answered this?
Yes, sir. So basically what you did was you first put sine to the other side and made sine inverse. So you did theta plus 20 is equal to sine inverse of half. We
Yes.
already knew what a sine inverse of half was, and that was 30 degrees. And then from there, what you did was you made it so that theta would just be on the left side, and then you moved 20 to the right side and subtracted both of them,
Correct.
knowing that there can be two different answers because of the two quadrants.
Get the idea. So that is how we could actually solve this. Now, this question could be tricky because I could have here theta equals to minus 40. Do you understand? Theta minus 40. Then it will cover 30 also, right?
Yes, sir.
So, test question. Sine theta minus 40 degrees is equals to half. Find theta where theta belongs to 0 to 360 degrees. Do you understand the question now? Now find the solution. This is your homework. I've just changed the question a bit. From theta plus 20, I made that argument. This is called the argument, right? Or the angle, right? This is also called the argument. I changed the argument to theta minus 40 degrees, right? You still know that the related acute angle is 30 degrees. But you have to give me two solutions where theta is between 0 to 360 degrees and sine theta minus 40 degrees is half. Is that clear? So that
Okay,
becomes
sir.
your test question. Submit the answer. Fine. Now let's look into other type of questions. Let me clear this. So here's another test question for you. Test question says that if tan theta equals to 3/4, find all possible values of sin theta and cos theta. How will you solve this particular question? Tell me.
So if tan of theta is equal to 3/4, right, sir? So then we have to find all possible values of sine theta and cosine theta.
Yes.
So we can first solve for tan theta by isolating theta and leaving it as tan inverse of 3/4.
Okay. Use calculator. Tell me the answer. What do you get?
So rounding it to the nearest degree, it would be 37 degrees.
Okay, give me one decimal, please.
So then in that case, it'll be 36.9 degrees if we're
Right.
rounding it by 10.
Yeah, 1/10. Yes. Okay. So theta is this. Okay. Now tell me all values of sin theta and cos theta. Will that be the complete answer, or you're looking for some other value of theta also?
Looking for some other value of theta as well.
Which is that some other value?
So the another value would be 216.9 degrees because
You're
we
right.
would do 180 plus 36.9.
Yes. So you're 36.9. The other is this 180 plus 36.9, right? So the other answer is 180 plus 36.9 degrees. And how much is that?
216.9 degrees.
So you have to give both, right? And in this quadrant, sine and cosine both will be negative, correct?
Yes, sir.
So you have to give two sets of values in your answer. If you give only one set, you will lose half of the marks. Do you understand? So quadrant 1 and quadrant 3. Do you see? And
Yes,
you
sir.
can use the calculator, or you can use this also, a triangle. We are saying tan theta is 3/4. Means this is 3, this is 4, right? So if that is the right angle triangle, right? So then the hypotenuse will be 3 square, 4 square, square, which will be 5, correct?
Yeah.
So the accurate value will be sine theta will be equal to 3/5. Cos theta will be 4/5. And here sine theta will be negative 3/5. And cos theta will be negative
Negative
4/5.
4/5.
You see, even without calculating the angle theta, we have found the answer.
Yes, sir. So
Important
basically
thing.
what we did was we just solved for quadrant 1, and by already knowing what the value is, it will always be the same for the other quadrants if the sides are always the same.
You're looking only for positive or negative sign. Values has to be same, correct? And the question never asked you for finding the angle. Why will you find it out? And if you find the angle and use this 36.9, use calculator, find sine of 36.9, what do you get?
You get 0.6.
Okay, fairly accurate, because this 0.9 is very close to 7, right? I mean, you get, there is very less approximation which we did. Anyway, but 3/5 is a better answer than any decimal value. You get the idea?
Yes, sir.
So if you're given an angle, I mean, like this, it is better to find the triangle and then do it. Let me take another example with you. This time I'm saying that sine theta is equal to minus 3/7. Find tan theta. Tell me, how will you do this?
So it's negative 3/7, right, sir?
Yes. Yes. What do you get?
Oh, I'm still solving for that. I just made my triangle and I was just finding out for A. I was using Pythagorean theorem to solve
That is
the.
correct. So 7 square minus 3 square, square root will give you the third side, right?
Yeah, so I
7
got
square.
2 root of 10 as my
That is correct.
answer for the third.
Now you can write down tan theta values, right? You're looking at this
Yeah,
angle as the theta. So what is tan theta?
so tan theta would be 3 over 2 root of 10. And to simplify that, we can't have a rational on the bottom, so we'll multiply both by a 2 root of 10. So it will just be 6 root of 10 over
3 root of 10 over 20.
3 root.
You'll only rationalize multiplying by square root 10, right?
Oh, yeah.
But don't
So
forget,
just
you have to work for both the quadrants, correct? And then
yes, sir.
also negative 3 root of 10 over 20. Both answers you have to provide. You get the idea.
Yes, sir.
Both answers you have to provide since we are working on theta, which is between 0 degrees to 360 degrees. Is that clear to you?
Yeah.
So that is the key. Perfect.
Yes, sir.
So that is what you should know to answer any question on this particular topic. Now, you can take up any question from your book and we'll try to solve it. Is it okay? So read any
Okay,
question
sir.
from your book. Read any question. Yeah, read question, any question.
So this is
Question
question number 8, and it says that use each trigonometric ratio to determine all values of theta to the nearest degree. If 0 degrees is greater than equal to theta, which is greater than equal to 360 degrees.
Yes.
So find sine of theta, which is equal to 0.4815. Tan of theta, which is equal to negative 0.1623.
Okay.
Cos of theta,
0. Okay, negative 0.6.
oh, negative 0.1623.
Why? Others you do, but let's try to understand the concept. So, can you answer this question? Sine theta is 0.4815.
So it says that's,
Theta. Yeah, tell me.
so we already have two values, right, sir?
We are
And
doing
we,
this question first. Part A. This is part B. So tell me what is theta? Answer the question.
so by looking at it, if you were to round it to the nearest degree, it should be 29 degrees, or if we're rounding it to the nearest tenth, 28.8 degrees.
So you basically did sine inverse of 0.4815 and you found this angle. How much you get?
So rounding it to the nearest tenth, it is 28.8 degrees.
And sine is positive in two quadrants, correct?
Yeah, so it
So
should
you
also be 28.8 degrees on quadrant 2.
180 minus. Which is how much?
151.2 degrees.
Correct. So you have to report both the angles. Is that clear?
Yes, sir.
For the second question, how will you do it? Similar approach, right? Minus.
Yeah.
So just forget about minus. You can write down tan of beta is equals to 0.1623. Find the related angle beta as tan inverse of 0.1623. Tell me what is it?
I got 9.2.
Okay, so that means a small angle 9.2. That's what you get. But you are given negative, means you want your answer in these two quadrants, correct?
Yes, sir.
So for your question, what is theta equals to? Tell me.
So,
Yeah, tell me.
It should be negative 9.2 as
no.
one angle.
No, because your angle is between 0 to 360, you have to always write positive answers. So the two answers will be 180 minus 9.2 and 360 minus 9.2. Okay? Principal
Oh,
angle
I
is
see, I
positive.
see.
Yeah. This and this. Tell me.
I got 350.8 degrees as 360 minus 9.2 degrees, and I got 170.8 degrees as 180 minus 9.2 degrees.
Clear. So this question is absolutely clear. That is how you're going to answer. Clear?
Okay, sir. So if it's ever negative, then what I have to do is I have to always keep my answers positive, but I have to understand where like my line is being drawn, right, sir?
Yes, yes.
And
Then
sir, what
you,
if our thing is greater than 360 degrees? Let's say instead of
yeah, we'll do it in
360
the next
degrees,
class.
it's 720.
Yeah, we could do. No problem. We could add, let's say, okay, let's create a question. Is it clear?
Okay, sir.
We call this as a co-function, co-terminal angle. Very co-terminal angles. What I'm trying to say here is, let us look at this angle, right? Now, this angle, you will say, let us say this is 30 degrees, okay? In that case, you could say going round like this will give you 300, correct? This is when theta is less than 360 degrees and greater than 0 degrees. How? I could reach the same point by going in, repeating one more circle. Do you see that? Do you understand?
Yes,
So that means one full circle is 360. So one angle is
360.
300 degrees, the other will be 300 plus 360, right? You'll, after one more circle, you are going to reach the same place, right? You can go many circles and come to the same point. Do you understand? One circle, then another circle, and then also you reach the same point. Do you see that? So you
Yes,
are
sir.
reaching
So it would always
on
be
the
the
same
same angle,
terminal
right?
arm. You are always reaching always on the same terminal arm, right? Therefore, these angles are called co-terminal angles. And they are separated by the period of sine and cosine, which is 360 degrees. So keep on adding 360 degrees. You get the idea. If your question wanted
Yes.
the answer between 360 and 720, in that case, you add 360 more to your list, answer and then get between that interval.
Okay, sir.
You get the idea. So let me give you a question, right? Let's say tan theta is equal to 1, where theta is between 360 degrees and 720 degrees. Now find the answer. We know tan of 45 is 1, correct?
Yes, sir.
But we want to give the answer when theta is between 360 and 720. How are you going to get the answer? So more, this is like
By
one
adding
full circle
360.
and then coming. Do you see that?
Yes,
Adding
yes.
360, you get the idea. So the two answers. So remember one thing, that the period of tan theta is 180 degrees. Period of sine and cosine theta is 360 degrees. Cosine and sine, they repeat after 360 degrees. However, tan repeats after every 180 degrees.
180.
So You can keep on adding 180, 180, 180. So the first answer is 45. Okay. That is not within this. Then you add 180. How much do you get?
225.
Which is again not, right? So again you add.
So then 270.
Okay. 270? No, no, no,
Yeah.
not 45. Sorry. 180, 180. Sorry. You keep on adding 180, right?
Yeah. So if you added 180, you get 405.
Again add 180.
So that'd be 585 degrees.
Now these are the two answers which are within this. Do you see that? Between 360 and 720.
Okay, sir. So
Keep on adding.
405 degrees would represent the first quadrant.
Yes.
So basically 405 degrees represents the first quadrant and 585 degrees represents the third quadrant.
Correct.
We can calculate angles that are between 0 and 360, as well as knowing about a better understanding of the cast rule and how we can solve for another angle other than looking in quadrant 1 and getting that angle by adding or subtracting by 180 or 360 degrees, and also looking at angles that go negative, so like going clockwise, and how we can still calculate those angles.
Perfect.
As well as having a better understanding of how to calculate angles with a longer range of not just 360, but maybe 720 and
any range, any angle. Very good.
And then along with that, like unit circle and how we can tell whether or not there can be an angle that can satisfy an equation.
Perfect. So that's great understanding. I will prefer you solve some questions from your book, and you can also look into my YouTube channel. Some videos will help you to understand better. With that, we'll end the class today. Keep learning. Thank you and all the best.